So in this video, we're going to learn how to find the standard error for probability calculations. So first, let's read the problem. In determining automobile mileage ratings, it was found that the miles per gallon in the city for a certain model is normally distributed, with a mean of 30 miles per gallon and a standard deviation of 1.7 miles per gallon. Suppose that the car manufacturer samples 5 cars from its assembly line and tests them for mileage ratings. What is the probability that the mean miles per gallon of the sample will be greater than 31 miles per gallon, and what is the probability that the mean miles per gallon of the sample will be less than 29.5 miles per gallon? So first, let's fill in the information that we already know. The mean is 30, our standard deviation is 1.7, and the sample size is 5. So now we can find the standard error, and the standard error equation is right here, and it's your standard deviation divided by the square root of your sample size. So we'll do the standard deviation is 1.7 divided by square root, which is SQRT, of our sample size. So we get 0.76. Now we can go on to finding the mean miles per gallon of the sample greater than 31 and less than 29.5. So we'll start with the less than. For this kind of problem, we use the normal distribution equation, which is norm.dist. Now for x, we always put in the number that we're finding if it's greater than or less than, so 29.5 in this case. Now we go on to the mean, the standard error we just calculated, and then for cumulative, you just put true. And we get 26%. Now when we're doing greater than, we do almost the same exact thing. We still use the normal distribution equation, except we take 1 and subtract the equation from it, because the normal distribution equation will give you less than 31, but you want greater than 31. So we do equals 1 minus normal distribution. Our x this time is going to be 31. Then we put in our mean, our standard error, and true. And we get 9%. So that's how you use standard error in probability calculations.